Hi everyone, this is a review of some of the skills from Precal that you'll need in calculus. Alright, so first problem is we're given a function and we're going to find the intercepts, the domain and range, and sketch the graph. So pretty elementary stuff. This is just algebra. Now, just straight from the function, I would hope that you would recognize a couple things. First of all, if we had a plus or minus in front of here, if we don't have one, but if we did, then hopefully you would recognize that, well, if I square both sides, okay, and then move the x squared over, I would have x squared plus y squared equals 9. This is a circle with a radius of 3, right? So we would have a circle going in all 4 quadrants. However, since we just have y equals and there is no plus or minus in front, hey, this is the square root function, right? So the parent function of square root just goes like this. It only exists in the first quadrant, okay, or it could exist in the second quadrant, I guess. But it's definitely not going to have anything down here. Now, with this in particular, okay, notice that we have an x squared. So, I mean, this is going to be similar, I guess, in concept to the parent function of the square root. Right? Because I have an x squared here, I can include some of the negative numbers, negative x values, okay? But can't include anything that will give me a value greater than 9 here. So we'll find that that's negative 3 to 3. But first thing we're going to do is find our x-intercept. Okay, so our x-intercept is where y equals 0. So I plug 0 in for y and solve for x. So I square both sides, move x squared over. I get x squared equals 9. So x equals plus or minus 3. All right, that makes sense. So I'm going to go ahead and graph those just because I can. All right, y-intercept is where x equals 0. So y is going to be the square root of 9 minus 0 squared, which is just the square root of 9, which in this case we're just going to say is 3. Okay, and again, because there was no plus or minus in front of here, we're going to imply that it's only positive. So I have a y value of 3 up here. Now, if you want to be a really good student, you could write out these points. Okay, I'm not expecting you to right now, but if you want to be a really good student, you could write out these points. Okay, our domain. Well, if we connect the dots here, I see that I do indeed just have a semicircle existing in the first and second quadrants. Okay, nothing down here, no y values that are negative because square root cannot output a negative. Okay, my domain, well, we start from the left, go to the right. Okay, domain's x values. So I start from negative 3, go to positive 3. And I'm going to include those points. So I say negative 3 to 3 inclusive. These brackets just mean that negative 3 and 3 are a part of my set of values, okay, that I can plug into my function. Okay, my range, we start from the bottom, and now we're here. Like Drake said, we start from the bottom, we go to the top. So my bottom y value is going to be 0. Okay, I start from the bottom. And then I go up until my function exists no more, which 3. Okay, now I can plug in, or I can get a y value of 0. I can get a y value of 3. So those are both inclusive. All right, let's keep going. Next, asymptotes, all the asymptotes. Okay, so we're going to find all the kinds, and then a couple other things to get to the graph. Okay, first thing I notice is that the degree of my numerator is 1 greater than the degree of my denominator. Okay, this tells me a couple things. I can expect to have horizontal asymptotes of infinity, okay, because my top is bigger, and I know I'm going to have a slant asymptote because the degree is 1 bigger. Okay, so first thing, horizontal asymptotes, those are limits to infinity. So limit as x approaches infinity of my function, and limit as x approaches negative infinity of my function. Okay, we have some rules. Maybe you remember them, maybe you don't, but if the top is bigger than the bottom in terms of the degree, so my degree up here is 2, because that's the biggest exponent. My degree on bottom is 1, because that's my biggest exponent, so top is bigger, so my answer is going to be infinity. Or you can think about it as essentially I have infinity squared, which is a huge number, divided by infinity, which is a huge number, but it's way smaller than infinity squared. So infinity squared is so much bigger than infinity that the answer is still going to be infinity. Okay, so same thing here. Okay, bigger on top, so my answer is going to be infinity, but I also have a negative here, so I have to consider how that's going to affect my answer. So if I plug a negative number on top, I get a negative squared, which is positive. If I plug a negative number on bottom, I just get a negative. A positive divided by negative is negative. So I'm going to have negative infinity as my answer. Vertical asymptotes, we only consider the bottom. We set it equal to 0 because that's where we have problems. And x equals 1 is going to be my vertical asymptote. Remember, this is a line. Slant is division. If you're comfortable with synthetic, you can go ahead and do it. I always do long division. Yeah, remember, you account for every single exponent. Hey, even if the term isn't there, you have to account for it. We divide, so x times x is x squared. Okay, you always subtract. These should always cancel, and we get 3x plus 0. Okay, and 3 times x is 3x. Always subtract. I end up with a remainder. Don't care what my remainder is. This is my slant asymptote. Y equals x plus 3. All right, let's clear some space. X-intercepts. Okay, well, my x-intercept is again where y equals 0. Now, we're only going to consider the numerator here, because if we set y equal to 0, we can just multiply the denominator to both sides and get rid of it. So we really only have to consider the numerator. Okay, we can factor and solve. So I get x equals 0 and negative 2 for my x-intercepts. Okay, now down below is y-intercepts, and that's where x equals 0. Well, if you plug 0 in, for everything you get 0 on top, negative 1 on bottom. So y equals 0 is also going to be an intercept. Okay, let's sketch a graph. So first thing we gotta do is sketch our vertical asymptote at 1. So dotted line. Okay, our slant asymptote is the line x plus 3. So I guess we go 3, go up 1 over 1, up 1 over 1, something like that. Okay, this is a pretty informal graph. All right, so I have my slants like that. Now I can expect an x-intercept at 0 and negative 2. So I know that my function will exist somewhere here. It'll pass through those. I also have a y-intercept at 0, so that's probably my y-intercept and my x-intercept. Okay, and all we really got to do is connect the dots. Now remember, when you have a function such as this, a rational function such as this, it's always going to exist either here and here or here and here. Okay, it's pretty much never going to be like here and here. It's always going to be across your asymptotes. Okay, so because I know my function exists in this part of the graph, then I know it's also going to exist on the opposite part of the graph. Okay, so I know that my function is going to follow my asymptotes like this. And I know my function is going to follow my asymptotes like this. Okay, pretty rough sketch, but you get the point. All right, number line time. No. All right, we have an inequality. And so we want to solve this. Well, let's solve this just like we normally would any normal polynomial. Right, so let's move everything to one side of the inequality. Okay, nothing special so far. I see everything has an x in it, so I can factor. I see that I have a quadratic here that I can factor. Okay, well, here's what I know so far. I need to make a number line. So that so much is obvious. I need certain points to test on this number line. Well, the zeros are a pretty good point to test on this number line. Keep in mind what we want to do. We want to know where my graph is less than or equal to 0. Okay, that's what we want to do. Or we want to know where the function is less than or equal to 0. Well, consider like a normal graph. Okay, we have the y-axis and the x-axis. Okay, well, these points on a normal graph would represent your zeros, right? So I have one at 0, I have one at 3, and I have one at negative 4. Okay, well, I want to know what my function is doing up here, and down here. Now, I don't need to know specifically where it's going. Okay, I don't need to know like what the y values are. I only need to know if it's above or below the x-axis. So I don't even need the y-axis there. That was too much. Come back. Okay, I don't even need the y-axis there. I only need to consider the x-axis because I only need to know if it's above or below. I don't actually need to know what the y values are, right? So that's exactly what we're doing here. I'm only considering the x-axis. The numbers I'm going to put are my x values. So 0, 3, -4. Okay, these are my zeros. Okay, this is where hopefully my graph crosses, or maybe not. Maybe it only touches, but at least that's where it touches the x-axis. Okay, and so that's what I'm going to test on my x-axis. Right, this is just my x-axis. Okay, one dimension. I want to know what's happening in between my points, though. I know what's happening at -4, 0, and 3. Okay, I hit 0. But I want to know what's happening in between them. So I pick a point and I test it. You can pick any point, so long as it's not one of these. All right, so I need to test a number smaller than -4. You could pick -5, -6, -7, -4.5, -10, okay, whatever. Whatever's easiest. Pick a point and test it. So I'm going to test -5. It's always going to be easier to plug it into your factored form here. So if I plug in -5, remember, I don't care about what number I get, I only care about the sign of that number. So if I plug in -5, okay, well, I have a negative here, times a negative, times a negative. Yeah, I don't care what the number is, I only care about the sign. 3 negatives make a negative. Okay, let's test a number between 0 and -4, maybe -2. So if I plug in -2, I have a negative. 4 minus 2 is positive. -2 minus 3 is negative. Okay, negative times a negative times a positive is positive. Okay, maybe let's test 1. Okay, so between 0 and 3, let's test 1. So if I plug 1 in, I get a positive. 1 plus 4 is positive, usually. 1 minus 3 is negative. Plus, plus, minus, that's a negative. Hey, I need to test any number bigger than 3. Let's try 4. So if I plug 4 in, I get a positive. 4 plus 4 is positive. 4 minus 3 is positive. All positives. Okay, now I didn't care where I was positive though. I only wanted to know where I was less than or equal to 0. Well, that's here and here. So I'm going to write out my intervals, and that's going to be my answer. So all numbers smaller than 4 up to, all numbers smaller than -4 up to -4. So negative infinity to -4. Okay, now I never include negative infinity because 4 is inclusive. Because I have this less than or equals to sign, I'm going to include 4. Union. Okay, I am 0 at 0. Okay, I hit 0 at 0. So because this is less than or equals to, I'm going to include 0 up to 3. And I include 3 because of the less than or equals to sign. Okay, if this was just a less than sign, we would have a lot more parentheses. All right, that's it. Let's solve some trigonometric equations. All right, so first thing I have is sine of 2x plus cosine of x. Now, we're going to have to use our double angle formula. Now, I don't really expect you to have that memorized at this point, but you need to at least know how to use it. Okay, so sine of 2x is equivalent to 2 sine of x cosine of x. Okay, again, if you had to look that up at this point, I wouldn't get mad at you. Well, what do these have in common? Well, this looks a lot easier, right? Now I can just solve this like I would any quadratic. Split it up, cosine of x equals 0, 2 sine of x plus 1 equals 0. Okay, and we solve. So x is going to be arctangent of cosine. I'm only between 0 and 2 pi. So x is going to be pi over 2 and 3 pi over 2. Right, this time I have sine of x equals -1/2. Right, so I think about what angles would give me -1/2 for a y value between 0 and 2 pi. So I get 7 pi over 6 and 11 pi over 6. Okay, not too bad. Not too bad, right? All right, limits. Finish strong. Limits. Okay, so there's a couple different strategies that we have for limits. Remember, the first thing you always need to do is plug in this number, see what happens. Okay, if you get 0 over 0, it means you need to do something else. All right, so first thing I'm going to do is plug in -4. So if I plug in -4, I get -4 cubed. I get -4 squared. Okay, so I get 0 over 0. Okay, again, this is called indeterminate form. Indeterminate form is not a bad thing, it just means you need to do something else. Okay, there's another step you have to take. Okay, so one of the things that we can do is factor. So I see the top is a sum of 2 cubes. So I'm going to factor that, and the bottom is a difference of 2 squares. So this is all really good for me. Okay, I can factor this. So x plus 4. So it's always opposite, sorry, same, opposite, and then always positive. Soap. All right, and then bottom, we factor x plus 4, x minus 4. Hey, look what cancels. And it turns out that that is what was causing all of my issues. I didn't need this. Go away. All right, that was causing all my issues. Now if I plug in -4, I have no more problems. So I get 16, I get plus 16 over -8. Right, that's good. So this is going to give you 48, and I should get -6. Great. Okay, and this one is going to be a rationalizing problem. Okay, we rationalize. All that means is we multiply by some square root. We want to cancel out the square root. Okay, and we're going to multiply by the conjugate. Conjugate. Okay. And again, the conjugate is just if you're given this function, the conjugate is a minus b. Okay, so we just flip the sign. So in this case, I have a rational situation up here. Okay, I have a square root. My conjugate would be just a plus sign. So I'm going to multiply top and bottom by x plus 4 plus 2. X plus 4 plus 2. So I'm multiplying by 1. Okay, but what's important is that you keep everything inside the square root the same. Okay, the only thing you're changing is this sign. Okay, and we're allowed to multiply because we're multiplying top and bottom. So I have the limit as x approaches 0. This should always cancel because these are the same. So the square root of anything times itself is just going to be whatever's on the inside. Okay, this is going to be 2. When you multiply 2 conjugates, you just multiply these. The inside will always cancel when you FOIL, and so -2 times 2 is -4. On bottom, it's easier to keep everything separate. Do not distribute. Okay, never distribute this. Well, again, look at what cancels. 4 minus 4. Okay, so that's convenient. And look at what else cancels. Okay, and this is why you do not want to distribute, because this should happen. Okay, if you did it right and that was the process that you should have followed, this should happen. So we have the limit x approaches 0 of 1 over square root of x plus 4 plus 2. And again, that's what was causing all my issues. I had a 0 in the denominator. That was bad. Now if I plug 0 in, I get 1 over the square root of 4 plus 2, which is going to be a fourth. Right? That's it for this video. I'll see y'all later.